Hello everyone, I am Dr. Venkateswararao. Today I am here with a new concept, that is buffer solutions. Before we are going to learn about buffer solutions, we should know the meaning of buffer. The actual meaning of buffer is that a person or a thing which reduces a shock or it forms a barrier between things. I repeat, the actual meaning of buffer is that a person or a thing which reduces a shock or forms a barrier between the things. For example, friends and family can provide a buffer against stress. When we are in stress, then if we spend some time with the family and friends, then our stress levels are optimized. And one more example is a shock absorber of a bike reduces the shock that we are experiencing in a pitted road. When we are traveling in a pitted road, we are often experiencing a shock, but that shock is optimized with the help of shock absorber. Okay, so coming to the buffer solutions, buffer solutions are very important in biology and medicine, because most of the biological reactions and enzymes need very specific pH ranges to take place. For example, human blood contains a buffer. Human blood contains a buffer of carbonic acid and bicarbonate anion to maintain the blood pH in the range of 7.35 to 7.45. Human blood pH is in the range of 7.35 to 7.45. So that human blood contains carbonic acid and bicarbonate anion buffer that to maintain the pH range between 7.35 to 7.45. You just imagine what would happen if our blood is not in that range. If our blood is not in this range, eventually that leads to death. Okay, a pH of less than 7.35 and more than 7.45 leads to death. What maintains that pH range in this what maintains? What makes sure that pH of human blood is in the range of 7.35 to 7.45? The buffer present in the human blood maintains the pH range between 7.35 to 7.45. Therefore, to maintain this pH range, human blood needs a buffer. That buffer, what is that buffer? Carbonic acid and bicarbonate anion buffer. Therefore, buffer is one which resists any change in pH on dilution or by addition of an acid or a base to it. Human beings are always consuming food which is having acidic in nature, and we are consuming food which is in basic nature, but our blood pH remains in the range of 7.35 to 7.45. What ensure that pH range between 7.35 to 7.45? The buffer present in the human blood maintains that pH range between 7.35 to 7.45. So to maintain the pH range, we need buffer. To maintain the optimum stress levels, we need a buffer. to maintain the shock that we are experiencing in a pitted road, to optimize the shock that we are experiencing in a pitted road, we need a buffer. So, in case of human blood, the carbonic acid and bicarbonate anion buffer maintains that pH range. Therefore, buffer solution or buffer solution is one which resists any change in pH on dilution or by addition of acid or by addition of base to it. Okay. So, maintaining the pH of a solutions at a particular pH is very difficult. If solution placed in air, if solution exposed to air, that absorbs carbon dioxide present in the air and that solution becomes acidic. If solution is stored in glass container or glass apparatus, the alkaline impurities present in the glass may dissolve in that and the pH may be changed. So, maintaining a solution at a definite pH is very difficult. Okay. So, for maintaining the pH in a specific range, we need a buffer. For example, in most of the syrups and medicines, syrups and medicines we are using buffers. Commonly used buffers are citrate buffer, acetate buffer. Okay. I hope you catch the you got the point and you understand the what is buffer. So, buffer is one or buffer solution is one which resists any change in pH on dilution or by addition of a strong acid or by addition of a strong base to it. Okay. So, there are now we shall see the different types of solutions. There are two types of buffer solutions are there. There are two types of buffer solutions are there. There are two types of buffer solutions are there. One is buffer solutions of a single substance. Buffer solutions of single substance. Buffer solutions of mixers. Okay, there are two types of buffer solutions. One is buffer solutions of a single substance, buffer solutions of mixtures. We shall see one by one. We shall see this type of buffer solutions one by one. So, first buffer solutions of a single substance. Buffer solutions of a single substance. Example for buffer solutions of single substance. Actually, these are the solutions of a salt of weak acid and weak base. These are the solutions of salt of weak acid and weak base. Example for a weak acid is acetic acid is weak acid. The best example and the familiar example for weak acid is acetic acid, and the weak base is NH4OH, ammonium hydroxide. This is the best example for weak base. So, buffer solutions of a single substance is a solution of salt of weak acid and weak base. So, salt formed by the weak acid and weak base. The solution formed from the weak acid and weak base is CH3COO NH4, ammonium acetate. Ammonium acetate. Ammonium acetate is the example for buffer solutions of a single substance. Okay, and one more example is benzoic acid. Benzoic acid. Benzoic acid. Benzoic acid is a best example for weak acid, and ammonium hydroxide is the best example for weak base. So combination of the salt, combination of benzoic acid and ammonium hydroxide is ammonium benzoate. Ammonium benzoate. So ammonium acetate and ammonium benzoate are these two are examples of a buffer solutions of a single substance. Buffer solutions of a single substance is a solution of salt of weak acid and weak base. Okay, now we shall see the buffer solutions of mixtures. Buffer solutions of mixtures. Buffer solutions of mixtures. Buffer solutions of mixtures are again two types. One is acidic buffer and the another one is basic buffer. One is acidic buffer and the another one is basic buffer. Now we shall see the acidic buffer. Acidic buffer. Acidic buffer is the example for buffer solutions of mixtures, and the acidic buffer is a solution of mixture of weak acid and a salt of weak acid with a strong base. I repeat, acidic buffer is a solution of mixture of weak acid and a salt of weak acid with a strong base. Okay, so acidic buffer is a mixture of solution of weak acid and salt of weak acid with strong base, Okay, so best example for weak acid is acetic acid and salt of weak acid with strong base. So weak acid is acetic acid and strong base is NaOH. So combination of weak acid with strong base, salt that is formed from the weak acid and a strong base is sodium acetate, CH3COO-Na. So this is the salt formed from the weak acid and a strong base. Okay, so this is the example for acidic buffer. Okay, and one more example for acidic buffer is phosphoric acid. Phosphoric acid is a weak acid and its salt, phosphoric acid is a weak acid and its salt with a strong base, that is example for Na2HPO4. Disodium hydrogen phosphate is the salt formed from the phosphoric acid and sodium hydroxide. Okay, there are two replaceable hydrogens and the two replaceable hydrogens are replaced by sodium. Okay, so phosphoric acid and salt of disodium hydrogen phosphate. This forms a acidic buffer, and the acetic acid and sodium acetate forms a acidic buffer. These are the best examples for acidic buffer. Of course, we have so many examples for acidic buffers. Boric acid plus salt formed from the boric acid with strong base. Okay, now there are several examples are there. Okay, next we shall see the basic buffer. Basic buffer. Basic buffer. I repeat, already I told you, basic buffer is the example for buffer solutions of mixtures, and basic buffer is a solution of mixture of weak base and salt of weak base with strong acid. I repeat, basic buffer is a mixture of solution of weak base and salt of weak base with strong acid. Okay, so basic buffer is a mixture of weak base plus and salt of weak base with strong acid. Okay, strong acid. So weak base, the familiar example for weak base is ammonium hydroxide, NH4OH. NH4OH is a example for weak base, and salt of weak base with strong acid. Example for strong acid is HCl, and the salt formed from the weak base and strong acid is NH4Cl, ammonium chloride. So mixture of ammonium hydroxide and salt and ammonium chloride forms the basic buffer. Okay, and one more example is ammonium hydroxide, and ammonium hydroxide is a weak base, and you please form a salt with the ammonium hydroxide with another strong acid. For example, if you take ammonium hydroxide and strong acid HNO3, okay, it forms a salt of NH4NO3. This is also an example for basic buffer. And there are another examples are there: aniline, pyridine. Pyridine is a weak base, and pyridinium hydrochloride. Pyridinium hydrochloride is example for weak base, and quinoline is a weak base. Quinolinium hydrochloride is a example for basic buffer. Therefore, I would like to sum up this concept. That is okay. I would like to sum up this lecture, that is buffer. So buffer solutions are very important in biology and medicine. Okay, because most of the biological reactions and enzymes need very specific pH range to take place. So buffer solution is one which resists any change in pH on dilution or by addition of strong acid or by addition of strong base to it. Okay, and there are and buffer solutions are highly needed in some biological reactions. For For example, if you take our human blood maintaining in the range of 7.35 to 7.45, that is being maintained by carbonic acid and bicarbonate anion buffer. Okay. So, and buffer solutions, there are two types of buffer solutions are there. One is buffer solutions of single substance, buffer solutions of single substance, and buffer solutions of mixtures. Okay, buffer solutions of mixtures. So, again buffer solutions of mixtures are two types. One is acidic buffer and another one is basic buffer. Okay, we already had gone through the examples for buffer solutions of single substances, buffer solutions of mixtures, that is acidic buffer and basic buffer. Okay, I hope you understand the concept of buffer. In the next video, I shall come up with a buffer action. Thank you.